Alright, hello everybody, this is Video Boy and welcome to this LibGDX 2D platformer tutorial mini-series. Today we're going to be creating the base classes that we're going to be using for this platformer. So the tile manager and a couple other little things there. And then the next two episodes will be dependent on what you would like to learn. So first I'll release the one on how to create maps that use the tiled map format, the .tmx files, so you guys can create tiles with that. And then the next tutorial after that will be how to make our own tile loader and render and all that stuff, so that we can make custom maps that randomly generate in the future, or if you guys just want to fool around with the maps using code and stuff like that, you guys will be able to do that. And then after that, we'll probably have two last episodes in this series. We'll be discussing how to have things like gravity and entities and stuff moving around that all collide with the map, no matter which kind of map you made. So that's pretty cool. So be sure to watch this video and get everything ready so that no matter which way you choose to go, it'll all work. Okay, so let's create a new LibGDX project. So let's download the setup. I'm going to go through this real quick since I already covered this in the beginner's tutorial series, so we're going to do this real quick. Alright, platformer tutorial, you create your package. Alright, and we're going to throw this in here real quick in the workspace. So don't forget, you need to have some sort of subfolder. I'm just going to call it Git since we're going to be using Git. I'm not going to have any of these. No box 2D. Hit generate, and within a couple seconds it should be ready. It's pretty fast these days. So alright, it's done. Over here. Whoops, need to import with Gradle. Get all that stuff in, and there you go. Okay, so now let's get started with the actual code for this. So let's open this thing up here. We're going to keep the libgdx image just for debugging, so we can keep that there. We'll keep the red background and everything. We don't want to render it though. Actually, it's not even start the sprite batch. Okay, so what we need to do is we need to create what you call an abstract class. So an abstract class is a base class that has different methods and things, but there's no actual code in the methods. What you need to do is that you need to make a subclass that fills up those methods with code depending on the subtype. So if you look here, you have your application adapter, and our platformer game extends the application adapter. So the application adapter itself says that, okay, there's a create and there's a render and there's a dispose method, but it probably doesn't have any code for it. Therefore, we need to specify it here in the platform game. So you guys will see why this makes sense later on. But basically, we're just creating a standard map class so that we can access different things from the map, like collision detection and things like that, whether you're using tiled or you're using our custom map. So we're going to create a package here. Just do .world. Okay, and now we're going to create a class in here. You can check mark the abstract thing here, and we're going to call it game map. Oh, I forgot to turn that off, but that's actually from my live streams, and it tells me whenever someone subscribed. So I'll turn that off, but yeah, that's pretty cool that it showed up in the tutorial. So thank you for subscribing. I have a little extra surprise for you there. Okay, so I'm just going to load that code up. Alright, so we're going to have several basic abstract methods. So okay, so we're going to have the render. I'll just copy these through here. We're going to have render. We're going to, of course, have update with a delta time. Delta time is always useful. And then our dispose. And we don't need any parameters there. Just import that stuff. Okay, so we're done the basic part, but there's still a couple other things I'm going to add here later. First, I just want to add in the actual tiles. So we can give attributes to tiles. So let's create a new enum. Make sure you call it enum. And we'll call it tile type. Okay, so an enum is basically a set of constant objects. So I showed you guys how to do constants before. You know, you had your public, static, final, int, and then you would have like, I think we use width, so you can use a number. So these are constant values. But what we need to do for this is we're going to have constant objects. So we're going to have one constant object for each type of tile. So I made some tiles here. I didn't put them in the assets folder yet. Here, I'll get them real quick. And so I have a couple of little tiles here, and I'll show them to you. And basically we're going to be using those for this. So here it is. This is all in the GitHub, by the way. I have a link in the description to it. So we have like a grass tile, dirt. This is a sky background tile, so it's just some blue. This is lava. That's a cloud with some transparency. That'll be able to, this will prove to us that we can use layers, which is cool. And that's some sort of like stone or cobblestone, whatever you want to call it. So, whoops, I didn't mean to close that. So we're going to create an enum for each one and give it different properties depending on what it does. So first things first, we need to actually create the constructor for a tile. So the constructor for tile types is private because they're all going to be initialized within this class. I don't even think it lets you make them public anyway. So okay, so we're going to create two constructors. We're going to have one where it's ID with a collidable variable, which will tell us if the tile can be collided with, and then we'll have a string name just for the fun of it. Maybe in the future, if we have you know, like you can break blocks or something, and then you'd be able to pick up that tile and things like that. That's another thing that's good with the having a custom tile map, is that you can modify the map and delete tiles and things like that. But I'll let you guys figure that stuff out with the knowledge you get from this tutorial series. And we're also going to have one float damage. We're probably going to implement that before the end of this tutorial series. Okay, we also need to create these variables. So the IDs are all going to be integers for this. And the reason we're mostly doing that is for compatibility with tiled, since it uses numbers. Misspelled float here. Okay, this one is just going to reference the other constructor. So it's going to have the ID, collidable, name, and the damage will default it to 0, so not all the tiles will have damage value, so we don't need to specify it if there isn't one. And then we just do this ID is equal to ID, this dot collidable is equal to collidable, this dot name is equal to name, this dot damage is equal to damage. Okay, so now we can actually start specifying some of the enums. So the normal naming convention for enums is to use a capital, just like a constant, so you use all caps. So for grass, okay, so this is how you do an enum. So you have the name of it, and then you use one of the constructors. So for grass, we're just going to use the first one. The ID is 1, because tiled uses 1 as their first ID, not 0, like we're used to. So we're going to have to stick with that. Whether it's collidable or not, so true, because we want entities to collide with it when they're walking around. And we also want to give it a name, so just call it grass like that. And we can copy these. I think we have 6 different ones. Yep. 1, 2, 3, 4, 5, 6. Perfect. Okay, I'll just fill in the IDs here real quick. Okay, and we need to make sure we get them in the right order. So next is dirt, and then sky. Okay, we'll update the names as well. What are the next ones? Lava, cloud, stone. Another nice thing with having this is that we can reference these different tile types directly by using the enum. So if we just say we're in a different class, just say we're here, and we want to give, like, we wouldn't be able to do this now, of course, but just say we want to give the player some tiles so they can build with. So we would be able to do like player dot give tiles, and then we can say, okay, you need the tile type. So in here we can just do tile type dot dirt, and we could give them some dirt, and then just say give them 5. I don't know if we're actually going to implement anything like that, but it just gives you an idea that it's pretty cool that we can actually specify it in the code like that, which is very nice. Okay. So now let's create some getters and setters for these. One really cool trick that I learned recently, thanks to someone on the stream, if you do Alt-Shift-S in Eclipse, it brings up this menu and you can generate a bunch of different things. So you can generate a constructor, and in this case we're going to use the getters and setters, but there's a bunch of other stuff too. So we're just going to get a bunch of getters here. Whoops. We're not gonna make any setters because we don't want to be able to change the value of different enums, of different things in enums. Okay, so this is mostly done. One thing we need to do is we need to have some sort of way to get the enum based on the ID that it is. So the best way to do this is to use a hash map. So I don't think I really talked about hash maps, but this is how you use them. And it's pretty useful for this kind of thing, definitely. So we'll call it tile map. So basically a hash map is like an array, except you don't have to have an index from 0 to some number. The index can be literally anything, as long as it's like an object with a hash or something, which is basically everything you can think of. You could even have a string here if you want, which I use a lot for Archipelago, or you can have anything really. You can even have objects. You can have an entity that refers to another one. So it's very neat. So what we're going to do is we're going to fill up this hash map, and then when we need to get the tile type with its ID, we'll be able to use this hash map to get it. So we're going to do what we call, I'm not sure what this is called, but it's like some sort of static method. So when the game is started and the class is run, this code will be run as well. So in this code we can now fill out this hash map. So let's do that. So we're going to do a for each loop here, and we're going to loop through each different tile type dot values. So dot values gives us an array of all the tile types in the enum, so all of these. So we're going to loop through all of them, and we're going to add each one to the hash map. Whoops, this has to be static. Tile map dot, and then to add something you need to do put. So first you put the integer index of it, so in this case would be tile type dot get ID, and then the actual value. So this, we just put tile type straight in there like that. Alright, there you go. Now let's create a static method to actually get the tile type based on the ID. So public static tile type get tile type by ID. I'll have an integer pass in here for the ID, and we just basically just have to return tile map dot get. So get is to get a tile type using the index, using the what you call the key. So this is the key and this is the value. So if you have the key, you can get the value. That's basically everything that a hash map is for. It's very useful for some things. Okay, so we have all this implemented now. Now basically what we need to do is go back to the game map and add a couple of other little things in here. And then we're basically going to be done for the first little bit here. And then we'll be able to get on to the next episode tomorrow. So I'm just going to get this set up here. Oh, there's a few other methods that I wanted to add as well that I forgot about. We're going to need them. So public abstract int get width, get height, and get layers. So this is going to give you the width, this will give you the height of course, and this will give you how many layers there are. So I'll show you how that works in the next 2 episodes. And finally, we have 2 more abstract ones we need to add. Abstract tile type this time, and this will be get tile type by location. This will take a layer as well. Take a float x and a float y. So let's add some documentation for it. This is always a good idea. So what you do to do that in Eclipse, you do /* or asterisk, and then it gives you this documentation, which is really nice. And you can say basically what the method does. So this method gets a tile by pixel position within the game world at a specified layer. So basically we provide it with a x and y, and it's going to tell us what tile is at that location, or what tile type is there. So then we will be able to get data about the tile, such as if it's collidable or not. That reminds me, collidable needs to be false for the sky, because we don't want to have collision with the sky. And then we just have one more, and then so it's almost the same thing. By coordinate. Actually, come to think of it, this doesn't even need to be abstract. So we'll just code it after. That's a tile at its coordinate within the map at a specified layer. Alright, looks good. Let's not make this abstract anymore. So sorry about that. basically this will just make it reference this because the calculation is very simple. So what we do is return this dot get tile type by coordinate. Okay, so we pass the layer, and we're going to need to pass the column and row. So let's create a constant here. We're going to need the tile size, which is 16, by the way. So we can copy this. And basically we just need to do a quick conversion. So we do, for the column is x divided by tile type dot tile size. And then for the y, basically the same thing. So basically how it works is that you get the location on the screen, well, in the game world, at the exact pixel, and then when we divide it by the size of the tiles, and we convert it to an integer, it gives us the actual location within the array that the tile exists in. And then with this function we can get it in the in wherever it is. If we're using a map that's from tiled, we can load it up from there, and if we're using our own custom thing, we would get it from an array. But we'll do that stuff tomorrow and the day after, so 2 new episodes coming out after this one. And yeah, we're back on track with the tutorials. I hope you guys enjoyed this one and you learned something. It's kind of just the basic, and then we're going to get into the more interesting stuff in the next few tutorials. So if you're new to the channel, please subscribe and like the video if you did. I'll see you guys next time. Goodbye.